All right, now a very important rule that we'll need is the zero exponent rule. Now, what this rule says is that when you raise anything to the zero power, like a over here, that what you get is simply 1. Now this is probably one of the most curious rules that you'll come across. After all, usually when you're dealing with 0, you're familiar with, say, multiplying by 0 and getting 0, or even adding 0 and then not changing anything. But why is it that when we take something to the 0 power, it becomes 1? Well, one reason that we do this is we want it to be consistent with the rest of our rules. After all, we've been building up a lot of other rules for combining things and repeated multiplication. We want it to mesh well with those other rules. So let's see how it actually does need to be defined as 1 so that it fits with everything else we're trying to do. I'm going to look at 6 to the 0 power times 6 squared, and we'll do this twice, okay? The first time that I go through this, I'm really going to end up using my product rule. The reason why I'm doing this is I have the 6 and the 6, they're both the same base, and that rule would say I simply need to add the exponents together. So this would be 6 to the 0 plus 2. Now the addition's not so bad. 0 plus 2 is 2. So this would end up being 36. Now, for this rule to stay consistent with that, I need it to also equal 36. And you can see that if I look at just 6 squared by itself, this guy over here, that does equal 36. So what should I call this thing to multiply by 36 so that my final result is 36? Well, you shouldn't have to think on that too long. There really is only one thing that I can call 6 to the 0. I must call it a 1 so that when it's multiplied by that 36, it still is a 36 as the final result. So it really is the only way that we can define something to the 0 power so that it mixes well with all the rest of our properties. Right, let's play around with this rule a little bit. All right, this new rule is the quotient rule. In this one, we're dealing with two things that have the same base, so a, and they are being divided. When we divide them like this, it looks like we can simply take their exponents and subtract them. So it's a lot like our product rule, only that one dealt with multiplication and addition. This one has division and subtraction. Some important things to note, of course, we must have the same base for this to work out. We're dealing with division, subtract. Let's look at a quick example to see why this might work. Let's look at 5 to the 4th power all over 5 squared. So suppose I knew nothing about the quotient rule. One way that I could just end up dealing with this is looking at it as repeated multiplication. I have 5 times 5 times 5. Then I could look at the bottom and say, okay, what is 5 squared? Well, that would be 5 times 5. And then I could go through canceling out my extra 5's in the top and in the bottom. So this would leave me with just 5 times 5, which is the same as 5 squared. Now, if we look at the result of this, what happened to the original versus the answer in the end, you can see that all we really had to do was subtract those exponents. 4 minus 2 does equal 2. So this is the way that we will handle things that have the same base, and we are dealing with division. We'll simply subtract their exponents. Now, unfortunately, this does lead to a very interesting situation, and potentially it might give us some negative exponents. To see why this might happen, again, let's use an example with numbers so we get a good sense of some of the strange things that we want to be prepared for. So in this one, I have 2 to the 4th power being divided by 2 to the 5th power. And the first way I'm going to handle this is I'm going to use my rule for the quotient rule. So this would be 2 to the 4 minus 5. Now if you take 4 and minus 5, you get 2 to the negative 1. Now I can see that that's what the product rule tells me to do, but what exactly does that mean to have 2 to the negative 1 power? After all, when we were dealing with just, say, whole numbers, then I would often look at this as repeated multiplication. But how could I multiply 2 by itself a negative 1 number of times? That just doesn't seem to make sense. Well, to really get a handle of what that means, I'm going to look at the original problem as, say, repeated multiplication. So this would be 2 times 2 times 2 times 2 all over 2 times 2 times 2 times 2 times 2. So I have 4 of them on top and 5 of them on the bottom. Now let's go through and cancel out all of our extra 2's. So 4 from the top, 4 from the bottom. You can see from doing this there's only one left, and it's on the bottom. So this would be 1/2. Now comes the important part. If we look at each sides of our work, we've used valid rules and we've done things correctly. So what I have here are two different expressions which are really the same thing. And this gives us a good clue on what we should do with those negative exponents. We want to interpret our negative exponents by putting the base into, say, the denominator of a fraction. That's really how we'll end up handling these things. Now, it will take a little bit more work to get comfortable with these, so let's see what else we can do. So the rule that we've just developed is anytime we have a base raised to a negative exponent, we will put it in the denominator of a fraction, and we will change that base, or we will change that exponent to a positive number. Another way to say that is if you have an expression raised to a negative power, it can be rewritten in the denominator with a positive power. Now this leads to something very interesting. If you have, say, a negative in the top of your fraction and a negative in the bottom, then what you can end up doing is changing the location of where those things end up. So I have a to the negative m. It was on the top, but now it's in the bottom. I had b to the negative n in the bottom. Now it's in the top. And so a good rule of thumb that I give my students to really keep track of what to do with that negative in the exponent is really think of it as changing the location of where something is. If the negative exponent is in the numerator, so think of the top, go ahead and move it to the bottom, that's your denominator, and make it positive. The other situation, if it's already in the bottom, that's your denominator, then move it to the numerator, the top, and again, make it positive. And that will really help you handle these in a nice, quick way. All right, now that we know a lot more about our exponents, and especially those negative ones, let's get into using them a bit more. So here I have I have 1/4 to the negative third power. One of the first rules I'm going to use is to spread out that negative 3 onto the top and bottom of my fraction. So I have 1 to the negative 3 power all over 4 to the negative 3 power. Now here's where I'm going to handle that negative exponent. So that 1 to the negative 3 on the top, I'm going to move it to the bottom and make its exponent positive. I'm going to do the same thing with the 4, so 4 to the negative 3, now it will go to the top and its exponent will now be positive as well. And then from here, I would just go through simplifying it. So 4 to the third power, 64. 1 to the third power is just 1, so 64. Not bad at all. Let's try the same thing with the next problem, and again, notice how things are changing location. So 2 to the negative third power. That'll end up in the bottom as 2 to the third. 3 to the negative fourth power, that one's going to go into the top as 3 to the fourth. And then we'll go ahead and simplify from here. Now there may be a few situations where some things will have positive exponents and some things will have negative exponents. The only ones that will change locations will be the ones with negative exponents. So if I have an example like x squared and y to the negative third, then the x squared will remain in the same spot, but the y must go into the bottom since it had the negative exponent. So watch out for those. All right, let's see if we can definitely combine many more of our rules together and simplify each of these expressions. We got lots of rules to keep track of, so we'll just do this carefully, bit by bit. All right, in this first one, I have x squared all over 2y to the third, and all of that is being raised to the negative 3 power. One of the biggest features I can see here is probably that fraction. So I'm going to give the negative 3 to the top and the bottom of my fraction. So here I have x squared, we'll give it a negative 3, and I'll do the same thing with the bottom. Now one thing I can see on the top is that I have x squared, and that is being in turn raised to another power. So our rule for that says we need to multiply the exponents, so x to the negative 6. All right, let's see what to do with the bottom. Well, in the bottom we actually have some multiplication in there. So 2 times y to the third. So I need to give that negative 3 to each of the pieces down here. All right, moving on bit by bit. I'll deal with that negative on the x and eventually that negative on the 2. But let's see what we need to do with the y to the third and the y to the negative 3. So the rule says I need to multiply those things together and get a negative 9. All right, I think I've used all of my product rules and power rules and quotient rule. It's time to use that negative exponent rule. So anything that has a negative exponent on it, if it was on the top, I'm going to put it in the bottom. If it was on the bottom, it's going to go right to the top. Also, let's see, in the bottom, x to the 6th, and that guy is done. In the top, 2 to the third, and y to the 9th. All right, one last thing to go ahead and clean this up. 2 to the third power is 8. So I'll just go ahead and put that in there. So our final simplified expression for this one is 8y to the 9th all over x to the 6th. It's quite a bit of work, but it really is what happens. Okay, looks good. Let's do another one. This one is 4h to the negative 5th all over m to the negative 2 times k. So I don't see a whole lot of rules in terms of spreading things out over multiplication, but one thing I do want to do is take care of those negative exponents. So I have one of them up here on the h and another one here on the m. Let me first write down the things that do not have negative exponents, since they'll be in exactly the same spot. The h to the negative 5th, I need to put that in the bottom as h to the 5th. And the m to the negative 2, it now needs to go to the top as m squared. Okay, so I would continue simplifying from here if I could, but I think I don't see anything else that has the same base, so I'll leave it as it is.